Thanks, Michael. So yeah, this is work done at the University of Washington with my collaborators Mausam and Dan Weld. So I'm sure you've all heard about crowdsourcing. Has enabled a lot of really exciting discoveries in science and also new applications in machine learning and things like that. So you've heard all these success stories. Suppose you want to actually try building a classifier to detect cars, let's say. So you've written your first instructions, which say, is this a car? Now maybe just check before you actually launch. You look through some more data and you come across this image. How many people think this is a car? All right, some mixed responses maybe. So maybe we better update our instructions to specify that it has to be a real, not a cartoon car. Okay, so now we've actually launched our task, and we see there's low inter-annotator agreement on this item. So some workers have said that the answer should be yes, some say that it should be no. So we better update our instructions again to specify that it has to be a car you can drive on a street, not a railroad car. This process again happens for multiple cars, maybe for interiors of cars, and you need to see exteriors in order for your classifier to work. So this is a complicated process where you have to typically interleave a couple of sub-processes, one of which is performing the actual task, and while you're doing this, usually your task definition changes, and this is known as concept evolution, like the last speaker referred to. Another part of the process is actually running the task to debug it, because initially you don't know what the models of the workers have in their minds. This could be viewed as a model mismatch problem. And you kind of alternate between these two and revise the instructions accordingly. And it's also important to revise the training and testing procedures that's been shown, because as your instructions grow more complicated, workers might not actually read it, and you might need to reinforce the concepts that are specified there. So the dirty secret of crowdsourcing is that this is a lot of work, but unless you don't do this, it doesn't work well. And a lot of people like to blame the workers or whatever, but we sort of take the view that a lot of this comes from misspecified tasks. So you don't have to take my word for it. Task design, other people have said that task design is a major problem. There's studies showing the difficulties for requesters, as well as the importance of task design on work quality. And also, the risk to workers of poorly specified tasks and unfair rejections is one of the main risks that workers face in these platforms. So also, crowdsourcing is just a fad, right? So we don't really care about this problem, maybe. Well, actually, by 2027, there's projected to be more freelancers than non-freelancers, so it's really important to help support requesters in designing good tasks. Okay, so I'm going to move on to looking at how can we design tools that support this range of processes, both performing the task, to define the task, as well as debugging the task, and coming up with training and testing procedures. So our system, Sprout, enables the requester to explore the task via prioritized bugs, essentially, discovered by the crowd. So this supports both the goals of exploration and task debugging in the sense that the crowd is it's prioritizing exploration based on these bugs. So the crowd identifies clusters of confusions and displays these and the system displays these to the requester for review. So here there's multiple cars, partial cars, railroad cars, like in our example. Afterwards, the requester can review these confusions and edit the instructions in response. And then the system will rerun the new instructions and debug the remaining errors, hopefully which are fewer after this process. So this loop repeats until debugging is no longer useful. And as I said, hopefully the number of confusions should decrease over time. We can visually display some more information provided by the crowd. Here I've shown color ranging from that shows the amount of disagreement. So ranging from all red indicates all no answers, green indicates all yes answers, somewhere in between is higher disagreement. And so the system prioritizes the largest, most confusing clusters to help focus the requester's effort. The system also shows requester progress towards addressing the issues as they drill down into the groups and explore the clusters. So finally, the system also provides an area for the requester to to come up with test questions that can be used to test understanding of the instructions. So you can just drag, this is a pictorial representation, but you can drag items into this section, either that should be answered yes or no, for instance. And the instructions also let you embed examples, as is good practice. Here there's this red example. And as you're typing and you reference an example, the system can also suggest related test questions for you to add to the instructions, because it has some sort of semantic embedding based on the crowd-powered debugging, which I haven't quite explained, but it can find related questions. So the requester can easily add one of these suggested questions by dragging it to one of the test question sections. So once the instructions have been defined, Sprout compiles the test questions into a training and testing workflow. So this is a very simple process that's been shown to improve quality. So first there's an interactive tutorial where workers get feedback after they answer questions. Then there's a test phase where workers are tested on what they learned in the interactive tutorial. If they don't pass, they're removed from the task. But if they do pass, then they move on and actually answer task questions. So this ensures that only workers who understand the instructions actually perform your task. So I don't really have time to go into all the details of the interface, but here's a view of the actual interface. So part A is the confusions, and there's little summary visualizations of the amount of disagreement in each confusion group. B is a section to drill down into the crowd-provided explanations. C, there's the instructions editor, and D is the test question area with the suggested test questions. So up to now, I've sort of just only talked about the requester-facing side. There's also a crowd-facing side of the system that powers the debugging process. So workers first perform the actual questions using the instructions in a work phase. Questions that have high disagreement are then move on to debugging by meta workers, which is a different set of workers, who diagnose whether this is actually an uncertain or ambiguous question. And then if it is, then they clarify the instructions to remove the ambiguity. If it's not, then they create a test question with the correct answer. So this is just a sample of the interface of the clarify step of the worker interface. So here the worker might be shown a picture of a railroad car, and they're asked to add a clarification bullet to the instructions. So here the worker could specify that railroad cars should be labeled no, for instance. The system just discards these labels of no because only the requester can actually ultimately decide on what the label should be, but we found that this was more natural for workers. And has some additional features like providing autocomplete to try to help cluster results more than they would otherwise be. So we conducted a user study to look at the pros and cons of this approach versus a baseline, and to learn how to better support task design. So requesters in our user study were given a goal. They were given an underspecified instructions prompt, like, is this a car? And they were asked to improve the instructions to remove ambiguity based on their own understanding of the concept. We used 2 domains from prior work, which were both car images and travel websites. Travel websites were high-resolution images of websites with a mixture of text and images that typically require more deeper analysis to understand. And the baseline that we compared to doesn't use the crowd, so instead the requester organizes the data themselves instead of the crowd. So this is called structured labeling, and this is a system that was built explicitly to support concept evolution. So the requester can drag items into these yes, maybe, or no sections. They can create groups, and they can defer judgments and move around items between the sections. So essentially, this allows the requester to do what the crowd was doing with Sprout. So we had a within subjects design where each participant used both interfaces, and we had 11 participants with varying amounts of crowdsourcing expertise. So we found that overall Sprout was preferred by the requesters. People said things like categorizing the inputs, showing me the cases where there was confusion, et cetera, made it super easy to identify cases that needed clarification. They also noted that the similarity metrics seem to be working great, and the suggested items are great for testing the points I emphasized in the instructions. So this is sort of borne out by the fact that many of the text questions that were actually suggested came from the suggestions. Thanks. So we also did a preliminary evaluation of the instruction comprehensiveness. We found that there were that requesters using Sprout wrote longer instructions and used more examples in the instructions, and also that they resolved more ambiguous categories than when they weren't using Sprout. And we evaluated this using experts to code the number of distinct categories. So we weren't able to control for the actual concept that the requesters had, because if you actually define that up front and give that to the requester, then this sort of negates the point of the study. So everyone came up with had their own different personal definitions, and this was one kind of confounding factor of the study. So we also found that, like many mixed initiative systems, some requesters liked the support and some didn't, so some wanted to use both tools. Some benefits of structured labeling include that there's no bias introduced by the exploration process, and also let the requester do the tasks themselves to a larger degree. But of course, the trade-off is that you don't get support. So most people saw value in both tools. So I wanted to give a kind of an overview of the space of Sprout in this larger task design tool landscape. So on the x-axis here, I've sort of plotted limited task support improvement versus actually the goal of task improvement support. And on the y-axis is limited exploration support versus using the crowd to actually structure the exploration process. So in the bottom left, we have this baseline of structured labeling, which wasn't actually intended for task improvement, but nicely pairs with task improvement, but it doesn't actually provide a lot of support for that or for exploration, because the requester has to actually organize the data set themselves. Revolt is another system that has the crowd cluster ambiguities, but it does so on the entire data set rather than Sprout, which seeks to do it on a small portion, improve the instructions to remove the ambiguity, and then iterate. So these are useful for different purposes. Revolt produces very reusable data sets that you can relabel and use and repurpose, and Sprout seeks to remove the ambiguity and lower the cost of the overall data collection process. There's also systems like Demo and Wingit, which are seeking to provide task improvement, but provide limited exploration support. And Sprout seeks to do both of these via these prioritized debugging. So some future work, I'm excited about expanding the roles further of workers and algorithms and supporting the requester. So I think you could try to automate the instructions further, and for instance, by inferring requester decisions. We could try to create even more engaging and progressive tutorials rather than the automated gated instruction that was created with Sprout. Also, I think workers contribute to interface design or workflow design. Previously, people have looked at workflow task decomposition, but these have typically involved a lot of effort from the requester and monitoring. So I think it will be exciting to try to fully automate these more. I think we also need more studies and actual field deployments to see how useful these things work in practice. And I'm also really excited about moving beyond labeling tasks and, for instance, looking at how can we support and define open-ended and creative tasks better than we do now. So I'd like to close and take questions.
Hi, Matt Leese, University of Texas, Austin. Jonathan, really nice work and a great talk, as always. I was thinking, if you look at, say, annotation tasks, the Linguistic Data Consortium does, often you have much higher complexity for say, implicit phenomena. The annotation guidelines get quite long. Or even if you look at the Google annotation guidelines for relevance, which is, you think of a simple task as something relevant or not, and yet their annotation guidelines go to 100 pages. So, as you start adding more exceptions and rules and things to specify that, I could imagine over time at some point it gets unwieldy. And we often think that, well, maybe workers won't read all that much, or as you start getting longer, you have to organize the stuff. So how do you deal with this thing about as you have more complex tasks or you start getting more and more details for all these rules, how do you manage the instructions so they're still manageable? Or at one point, do you have to sort of figure that even though another rule would be more specific, it would become too long for the workers to actually make useful use of?
Yeah, so I think that's a really good question. We sort of pointed on that issue by just looking at this first step iteration. But I think designing better tools to support navigating larger sets of instructions, maybe having the machines suggest portions of the instructions that are relevant to certain questions might help. Or identifying which parts of the instructions are actually important for large sets of questions. So I think the requester could define that, but I think there's also roles for workers or automated approaches in helping with that part.
I've also got a question. In the theme of R2, who's often very confident and wrong, you have that situation very commonly with human interpretations, right, where we're going to have a false negative problem with this kind of system where the workers may not disagree at all, but the requester would have an entirely different interpretation. And this is going to be sort of blind from the requester's perspective. They're going to think, oh, great, I've covered all the cases, when in fact, if they went and looked at the results, they'd say, oh my gosh, they're getting it all wrong or something like this. Yeah. How do we expand this kind of tool to support that case?
Yeah, so I think we don't want to only look at the cases that have confusion. So the system also does display these other cases. I think that like the similarity metrics could help to try to do clustering on the cases where workers don't disagree. So in those cases, workers were